Okay, merhaba. Burada olduğum için çok mutluyum. Thank you. Every time I'm coming here, it's feel like home. We have so much in common, so I'm really, really happy. And thank you very much for the invitation. It's honor and pleasure for me to be here with you and share some of the projects and knowledge that we have obtained all these years. I will dive directly to the topic, which is today's agenda will be followed by some philosophical questions, asking that things that we ask all together. Research, what is the situation in our country, in Athens, regarding health, indoor environment, energy poverty, affordable housing, and etc. Some of the implemented solutions and sharing our methodology, how we treat special buildings like hospitals, like heritage buildings that you also have here in Turkey. And we will conclude with some projects and conclusions. So the first question is, why do we need to build passive? And one question before is, why do we build? This is the first question. Since ages, buildings are heated up with fire and try to create a warm environment and a friendly environment and a safe environment. Unfortunately, today we have the same heating system. So this is a major problem for our industry, which shows that we haven't been evolved enough to change the heating system, and it still remains a fire which emits, which creates a problem to the building and to the outdoor spaces. So questioning why I'm not comfortable today is many reasons today. For example, the mini split unit dries up the air so fast, and it's the worst possible heating system. The building is very dry. The surfaces are remaining cold. I'm feeling terrible. So second, the new windows are super sealed. They create a very airtight building, and no one opens enough the windows, or not opens because it's so cold outside or so warm. So the building CO2 concentration raises, again a problem. Of course, we have a lot of condensation in our buildings because we don't pay attention in details like thermal bridging. For example, double glazing windows have an aluminum spacer, a cold surface, so again condensation. This is in every building, not in Turkey, in Greece, it's everywhere. And last but not least, when we don't have enough money to heat up our house, then condensation and mold is growing. So this is today's problem, let's say, that we are all facing. So what the people need? They need to be warm, they need to be safe, to feel safe, to have a good temperature. But is that measurable? Yes, it is. I'm not here to speak ideas, I'm speaking numbers. So this is for us super important to identify and quantify results. So this is some very simple indicators, which are temperature, relative humidity, surface temperature, VOC, CO2, depending on materials, but mainly depending on the building, because we don't design the materials, we design the building. So the solution these days are the green buildings, the sustainable buildings, that the green certifications, which are all good and are applicable. But when you search in Google green building, you see a garden. So my problem here as scientist of building physics is, should I change to be a gardener, or should we continue to evolve and to provide good indoor environment and decrease the energy consumption? Because we have seen green buildings and another building for the mechanical system because they consume so much. So the real solution, which is the passive house is not a religion. It's not passive house or something. It's not building A, B, C, D. No, it's a tool. You can use this tool, which is fundamental principle of physics, in order to create your buildings with straw, your building with wood, your building with whatever you want. It's a tool. So using the tool, which is physics, at the end of the day, it's so simple, provide solution. How the people understand passive house? This one. So it's marketed from Germany like a very compact building with a lot of numbers and simulations. But at the end of the day, what is passive house is doing this. Is affordable, is healthy, is durable, is quiet, no dust inside, no humidity. This is what offers. And of course it can be whatever. It can be from historical buildings. The second building on the right-hand side is here in Turkey. It can be a huge project like the building that we certified, Stefanos certified in Germany, large development. It can be multifamily buildings, it can be ugly, it can be beautiful, it can be whatever. It can be expensive, it can be cheap. The fundamental is to be decrease in the consumption, increase quality. So, quickly introduction of ourselves. I'm here with 3 hats, representing 3 organizations. First is Hellen Pasif Ev Enstitüsü'nden. We do mainly research through European funded projects, but also with manufacturers. We do education and policy making, among others. We develop software, etc. The second is our private company. We are doing consultancy in Greece, try more in Greece than worldwide, but also worldwide, construction and project management. And the third is my university, where I'm a researcher, and we try to involve the students to the job site, to the working, through applied research. So, all these years we have proceeded with some research key points, which turned out to be very informative according to the ideas that we need to develop. So one case study is Athens. We have 6.1 million buildings in Greece. Almost 500,000 are in Athens, and almost 80% are totally uninsulated. So what we did is that we tried to first model the area. This is more scientific for the researchers here, how we simulate dynamically the region. Unfortunately, not every topography is sufficient to be entered to the softwares, so we translate some documents, some files to others in order to have this, which is the calculations, among others, according to the thermal comfort. So only the green part of this area, the area is, I go back a bit, is here on the right hand side in the center of Athens, the blue buildings. All these areas are comfortable. So imagine the time of the year, according to simulations, that it's totally uncomfortable areas, occupied, unoccupied building, offices and houses. So this simulation. But we said simulations and field investigation combined. So we went on the field and we did an investigation. The first of our projects was 49 flats, energy audit. We were there, we spoke with the people, so we have qualitative and quantitative results. We measured indoor conditions, relative humidity, temperature, and we analyzed, according to our software, every flat, what is the potential of each flat. This is in Athens. So one interesting result to share with you is that when you see the red line, it's the temperature inside. So this is 28 degrees during the summer, average. And we asked the users if they are feeling comfortable. And 56% answered, yes, I'm comfortable, after 28 degrees. And the average temperature was 31.4. So this is called, in science, adaptive comfort. But in my mind, my science is called, I don't have money to pay and I have terrible buildings. So I'm not expecting you to be adaptive in your houses, and you're expecting to us to create better buildings. So this shows that, yes, they feel comfortable because they have no alternative in their life. They think that cannot be improved from questionnaires, from interviews, etc. So the solutions, because I talked about the problems, now come to the solutions. The solution is the passive house in a methodology. Our methodology, your methodology should be different. But I want to share what we all these years we have achieved through this methodology, which is 6 steps. The first step and the last step are also connected. So it starts from energy design, going to implementation design, technical details, go to selection of materials, which is also important for the conference here. Materials super important, but more important than materials are the systems, combination of materials. Fourth is on-site implementation, like we supervise our project. We don't just design because we tried, it's impossible to not supervise. And fifth, quality assurance. We checked our buildings with blower door test, with thermography, with monitoring, with everything. And the sixth is monitoring devices, which optimizing performance of the systems, but also checking for insufficiencies in comparison to step 1, the study. So when we say to the client, you will consume for 100 square meter, €1 per square meter, so €100 for heating and cooling, we need to evaluate that and to evaluate ourselves first, because we sign for that. We sign that they will consume nothing and they will have perfect conditions, because I can also consume nothing while having 12 degrees or 30 degrees inside. So I'm energy efficient, but not comfortable. And this is the results. So for me, for us, results should be like this. Like when you see, for example, the red line, you see what is measured. When you see the black line, you see what is theoretical. So theoretical energy consumption and measured energy consumption is close. It doesn't have to be lower or higher, of course, is worse, but lower. It has to be exactly this. That's what makes a good design good design. The numbers, the quality assurance, and the results. And the same for cooling, right, on the right-hand side. Sharing some projects with you. One is the hospital, as I mentioned, and the other are one, basically, historical building, 35 years old. So the hospital is this one, is in Thessaloniki. It serves an oncology center. Our primary focus of design was to reduce energy consumption and to improve thermal comfort. This was the idea. But we realized that according to the design, the doctors and the patients were super happy because of the illuminants. We want the light inside the winter because it's our heating system. They were super happy because of noise, the reduction of noise. They were super happy because then they didn't see any dust. So all these things is not related to the passive house concept. It's after the passive house concept, a consequence, a good consequence to the design. So during the design phase, even if it's a passive house, we say we have the most efficient buildings and the most best performed buildings. But if the architect here didn't have a plan, the building is going to be certified. But imagine even in a room, we did an analysis, and even in a passive house, the room can be overheated and can reach 31 degrees during the summer if it's not shaded. Total building is okay, but we need to take care also specific rooms. So we did also that very detailed and advanced analysis, let's say, which in my opinion was useless because the mechanical engineer and the constructor at the beginning claimed that this is our wall. So we dig deeper to analyze rooms, but they claimed that one wall has a U value of 0.23, which in the reality is 0.55, because they didn't take into consideration in the U value the metallic studs. So even in the simplest thing, we are not safe. We need to take care of everything. And imagine a building lacking 10 centimeters of insulation. So we prioritize the problem to fix the wall. So from 10,000 square meter, we go now to 65 and 140, which is the building, and from 300 or 400, I don't know, millions of and hundreds of engineers to 2. So this is the first EnerFit, which is Passive House certification for renovation museum in the world. Again, very low energy consumption, but here we need to make a detailed analysis, which, because the insulation is from inside, to preserve the exterior facade. We need to do hydrothermal simulation, design the materials, detailed thermal bridge analysis, structural analysis also, and of course we understood that airtight is not vapor tight. Fraunhofer Institute has software called WUFI, is in my opinion the best software for hydrothermal simulations. Again, we're speaking about materials, but materials are not important if we don't design the wall. So we did several calculations, and okay, if I explain this, it will take 1 hour. What I want to say is two things. First of all, even the worst insulation for interior, which is XPS or EPS, which is not vapor permeable, some call breathable, it's not, can work in a good combination with the others. Even the worst. But even the best material, super vapor open, and can be destroyed if we have a plaster which is vapor tight, because the condensation is not inside the material. You will never see condensation inside. You will see in the connection between the materials. It's just layers. So we have to be very sure about the materials, and in every kind of this analysis, I'm writing at the end, we can never be sure about the properties of the bricks, which are 150 years. If we want to be correct, we need to take the bricks to the laboratory and to check the properties and then simulate. Because simulation, again, and software is just a tool. It's not the knowledge, it's the tool. The building is working 2 years. It's everyone's very happy. They are preserving also art, sculptures and paintings and everything. So they are very happy, and for us it's one of the most difficult projects and best examples. So, last but not least, some conclusions. This is from users, because our best marketing is the users. For us, it was first time we heard that a mother told us that my daughter didn't have problem with asthma because of mechanical ventilation and airtight building. Because if you do airtight building and not mechanical ventilation, it's worse than keep everything open. This year, I didn't catch any flu. I'm waking up like living in a forest. You changed my life. And when we ask, what about the bills? Which bills? I mean, for them, it's not anymore important. It's important that they are living in a healthy environment. And this is an example from Turkey, from, I think, one of the first projects that was certified. And it was 4 degrees outside. And the user said, we haven't needed any heating yet. The comfort is incredible. Everyone is speaking about the comfort, which is, for us, the major topic. Which is a good consequence of the passive house and building physics. This is last slide I added because I changed my grandmother's filters in a passive house apartment after 6 months. It's this one. It's totally dark. And imagine that she lives close to the mountain in the suburban area of Athens. So imagine when we open the windows and we say natural ventilation in cities. Yes, not very natural. Very polluted, yes. Natural ventilation is a filter ventilation. That's why we inspired from the nose to filter the air. It's the same thing. So with that, she doesn't have dust, and I don't have that scream, open the windows every morning when I sleep there, which is, I think, common in Turkey as well. In Greece, it's mandatory for grandmothers. So passive house saves me from that noise early in the morning. I agree with many of the speakers and said from the early beginning that we should create stupid buildings, not smart, simple buildings. This is super important, and don't search for novelty because many of the things are sold. We should not compromise with our health, super important. And it's medicine, pills, or passive house, a better building. This is my point of view, our point of view. This is our team, which all this presentation is not my work. It's a work of entire team that more people should be here in that slide. We try our best to combine all the time science, research, and practical results. And for us, passive house is beyond science, is creating for the people. Thank you very much.